Yes friends, we are on Life Processes Lecture 8 at Galaxy Tutorials and I'm Professor Kumar. We are doing a new subtopic, transportation in life processes. I remind you, please see the video lecture, take down, jot down, note down important points and kindly refer to the study pack for the detailed question answers given behind each and every subtopic, which is questions and there is a box. And at the end of the chapter, the answers given in our study pack are from marking scheme. Not copied from any guide. We do not need any book, any guide, nothing. This is what is asked, this is what is corrected. Besides, it marks and tells you which of these questions have come in the previous paper. Besides, it tells you what are the other questions in the question bank from which paper is being set. All these facilities you can see in the study pack. Let us begin the lecture. And sorry, I must remind you once again, please subscribe to the channel so that you are notified. See, today at various phases of the day, I have uploaded different videos. You will not know. You will see night, you will forget to see it next day. Then you will have 6 videos at one time to see. Kindly subscribe to the channel Kumar Sir-Galaxy Tutorials. Press the bell icon. You are notified. You know what you have to see. You can plan when you have to see. You can ask questions when you cannot follow. And you can communicate. Let us see transportation. First, why we need transportation? My friends, as you know, in these COVID times, we cannot travel. There is no local train in Mumbai. They have told us 2 kilometers beyond you cannot travel on your bike. Transportation is now being controlled so that the spread of the disease can be controlled. Now, what is transportation in our body? My friends, you studied respiration. You studied oxygen is carried by the blood. The blood transports oxygen through hemoglobin and some part dissolved to each and every cell of the body. Each cell can't come out to the lung, take oxygen and go back. There is no pipeline which is running inside in which oxygen, we don't have a gas pipeline. Okay, we have a blood pipeline because we have to bend, we have to move. Transportation is important for first, transportation of oxygen. Second, transportation of waste. We bring back CO2 and other waste from the body inside to the outside to be thrown out. Third, we are transporting salts. The plasma of the blood contains dissolved salt. Minerals are required. Anytime you are not well or your system is not functioning, doctor gives you tablet. Those tablets are absorbed finally into your blood and taken by it and transported to the cells. Okay, you got a headache, you take crocin, got fever. So you see, transportation is important. Your stomach does not cure. Each and every cell temperature has to be brought down. So salts are done. It helps to transport hormones. Hormones are chemical messengers made by the brain and transported. You see, people have thyroid because the thyroxine hormone is not being transported, not being manufactured. You have diabetes because insulin is not being transported. Hormones. Like this, you can see, we can go on n number of points, but we will never require 20 points. 1 mark answer. Why transportation is necessary for the body. Please remember, all the nutrients have to be transported to every cell. You cannot repair any part of the body and you will never grow. Cell cannot divide unless it has a raw material in double. How will it make 2 singles? Okay, so that is why transportation is important process of the human body, of any organism body. Since we are dealing with humans, human body. Let's go further. Number 2. In our body, we have circulatory system. as the transporter. Okay, he will transport all the things. It is made up of blood, the liquid portion, and heart, the pump. The blood, my friends, has got plasma, the liquid portion, and it has got cells, the cellular portion. Plasma is the liquid portion. Cells are RBCs, WBCs, and platelets. So, this is the truck, train, plane where we are transporting the substances. You see your WBCs are fighting, capture the germs, break them down, throw out the waste. RBC, transporting oxygen to each and every cell of the body with hemoglobin. Platelets, break down, clot the blood. In dengue and as you know chikungunya, platelet count decreases. That's why we have to take him to hospital. Doctor will not treat you. This is circulatory system ka vehicle, transport machine. Who is pushing these machines? Who is the owner? Who is the one who is working hard? Is the heart. Heart is the pump of the body. And my friends, you very well know that if this pump stops working, medically you may say anything, heart attack, anything, the person dies. This person pump works on its own, does not get tired, okay, and till the end of the life works perfectly. It knows how much to repair it. Of course it gets old, everything gets old. I have an old car, I have a 15-year-old car, you have to maintain it. Okay, so these are the two important points. Now, I will see third point, human heart. Here I will have a diagram and of course labels of the human heart, very important. People say that is so difficult. I will teach you how to draw and remember simply. And I will have the pathway of flow of blood. How does heart transport the blood, liquid portion through, as you know, arteries, veins, and capillaries. These are not part of the heart. These go from the heart. Or, simple language, blood vessels. This is the road on which the truck is running. Okay? This is what is the empty place in the truck. This is the truck. That is how we are transporting. So, this is what I will be teaching you in today's lecture on this topic. Let us go in details. Okay? Number one, we are looking at the human heart. How do we draw the human heart? Keep track with me. I could have drawn it first and kept it for you, but I do not want to save time because it is very difficult for you to draw. Everybody keeps grumbling and complaining. Please have a look on how to draw. Number one, you draw heart in a slightly inclined position. Why? Remember, respiration between the left lung, heart is lying in that place. Number two, double wall this structure. Top is thin, bottom is wavy and thick. Number two, learn step by step with me. Number three, draw the middle line roughly, and here first put the valves. Put the valves first, because otherwise they will never fit. portion. Now, what you got left? You may join. You see, this is how structure of the heart will start. Now, the details. From the left side, where I've got the left side, I will have a pipe which you will see goes on top. Now from this side, I will have a pipe which will go across. X, but the bottom of the X is down. There is no center. That is it. Now you may complete the middle wall. Whatever is seen, you may complete. Your diagram is ready. Otherwise, it will never fit. You keep taking your eraser and wasting time. Now there is a blood vessel here, big pipe, pre-cable. Now we can't show it comes inside, so we should dot it, and a hole will be seen. There will be a blood which brings blood from the legs. So we will show it like this. Only hole will be seen. Here I will have small pipe-like blood vessels with small holes can be seen here, and I have two here also. Here I will attach some thread like connective tissue, and we are now ready to label. Okay, number one, I remind you, right hand is left for labeling, left, and this is also left, this is right. This is also right. Upper, there are four chambers. 1, 2, 3, 4. Upper chambers are called auricles. They are also called atrium. Atria is plural. Don't use both. Use any one. So left auricle, right ventricle, and left ventricle are the four chambers of the heart. Then the wall in between is called septum, partition. The partition. Okay. These thread-like are chordae, tendinae, Latin. Tender cords, fine thread-like tissue, keeps the valve down. So the ventricle contract, the valve will open up, blood will go up, everything will get mixed and spoiled. Now you can see whenever we are tying talpatri or plastic, we tie bricks, okay, so that it does not fly upward when the wind comes. Columnae, chordae, tendinae. These appear like columns outside. And their muscles, these are papillary muscles. Papilla, swelling. Okay, like we get papilla on the boils you get on your face. Okay, and the thick wall is columnae, carne. The thick columns which support. Now this is 2D here. All these columns will come here. There will be a heart. We have cut. So if I cut a pen and show you like this, you only see circle. All these circles on top, now you see column. So they pop up the heart like pillars. Then, now you can see I have got valves on both the sides. Now these valves will take care that the blood does not go into the reverse chamber. So they open like flap and they close, they fix. They do not open upwards. So bicuspid valve and tricuspid valve. Why am I calling them bicuspid? Because if I cut and show you the circle, one will have 2 flaps and one will have 3 flaps. Bi is 2, tri is 3. But I cannot draw 3. Third one is here. Coming out, can't draw. So we are unable to justify. So these are simple diagrams. Of course, if I cut the heart, you can't see everything like this. This is diagrammatic. Something will be on top, something will be behind. Everything won't appear. Okay, we have fitted everything into the diagram for understanding. This is pre-cable, bringing blood, as you can see, from the body into the heart. This is post-cable. From your leg, all the blood is brought back to the heart. These are major veins. They bring the blood to the heart. Veins bring blood to the heart from the body. Okay, and then we have. Now let's come to the arteries. This is aorta, the largest artery in the human body. So it comes out, takes a turn, and then gives branches to all the parts. This comes down, and now you can see we are calling radial artery. We see pulse, we see blood pressure. Because same level as heart. I can't measure on my heart, I can measure on the levels. So YouTube, as our blood pressure is taken on the arm, the doctor will say lie down or sit, so that the heart and they are at the same level, and then we take the reading. So physics says in a YouTube, liquid will have same level in both the arms. This is pulmonary trunk. It takes blood to the lungs for purification. Used blood goes here and good blood rich in oxygen goes here. So it comes here, okay, leaves here and finally goes like this. It comes here, okay, goes here and finally goes out like this. That is how blood. So we will be seeing path of flow of blood. I have dealt with human heart diagram. Do we ever remember so much? No. Initially, we will learn 4 chambers. 1, 2, 3, and 4. 4 chambers. Then we will learn the 2 main branches for artery. We will learn 2 main branches for vein. And we will not learn anything much more. We just say valves. We don't have to even remember bicuspid and tricuspid for drawing purpose. Okay, that is all what we require to remember in the exam for drawing. But since you're going to learn the answer, since you're going to learn the notes, that is why I put all the points which are appearing in the notes so you can imagine, visualize, see and understand better. Okay, once again, how to remember the diagram? Please give me a look. I will give you a shortcut how to remember. Diagram is very simple, important, so we have to learn. Let's go for it. Okay, so first, how do I remember my diagram? First and foremost, we will first see that my heart is tilted. Okay, I'm making the light so that I don't have to rub afterwards. So first, second, third, fourth. 4 chambers of mine are ready. Then double up. This is thin and this is thick, wavy. Step number 2. Step number 3, draw the valves. When you come here, draw the valves first, otherwise they will not fit. Then put an X with the bottom portion, it's not in the center, at the bottom. Here, make a double pipe, goes outside. Here, make a double pipe and it will go out. This one you turn in a U, this one you turn in a T. Don't forget. See how easy to remember. Okay, don't have to remember, oh, it gives rise to 3 branches. Don't go much for details first. First learn the basic structure. Then start completing the middle wall. Okay, and this one, prepare thick but straight. Ventricles are thick walled because they pump out the blood. Auricles are thin walled because they receive the blood. Okay, so we have to distinguish between the chambers. So this is how, and of course you will have one pipe here, you will have one pipe here, you will have set of pipes here and some what you can draw here. And your diagram is complete. Diagram is not difficult to draw. Okay, and also remember, right hand side is left and left hand side is right. Otherwise, all gadbad will occur. Top is auricles, bottom is ventricles. So simple. And of course, you will be able to now draw and write. So I showed you an easy method. First outline, then the valves, then the X, and then you complete the diagram. And remember, X, the intersection is at the bottom. And your life will be very easy. Okay, slowly shape will come and you will grow your heart, and best of your heart will be developed by the time Valentine's Day will come, so don't worry. So you have to start practicing. It will not come immediately. Okay, so this is at least proportionate, better, will get me full marks. It may look narrow or wide, no problems. All chambers, all labelings, everything is there. Auricles are small, ventricles are big, auricles are thin, ventricles are thick. See the difference? Right is bigger, left is smaller, everything is seen in my diagram because of the tilt. Okay, so we will go for now how blood flows in the body. In transportation, flow of blood. The pathway I will teach you. What is so great about it? Because question comes in the exam. We are having double circulation in higher animals because we need efficient circulation. We require oxygen immediately. My brain needs oxygen to think. You know, we go in coma if the oxygen will go low. Okay? Frog does not need that much decision. He's slow. So mine has to be fast. I have double circulation. All higher animals, mostly all vertebrates, show double circulation. But fish and all, water enters on one side, goes on the other. They don't need because gills are doing all the work. For us, not possible because we take in through, go to every cell, difficult. So higher animals show double circulation. What is the meaning of double circulation in single? In single circulation, blood will go, blood will come out. Your pathway is complete. In double, blood will go in 2 different directions. Go here also, go there also, and come back from both the directions simultaneously. So, at one time, 2 cycles are running. Okay, I have got 2 gas and I am preparing chapatis on both the gas at the same time. Double circulation for efficiency. Why do I need double? Because my body is long and complex. I need blood on the top side of the heart, I need blood from my bottom side of the heart. My heart is somewhere more located towards the center. Towards, not at the center. So, and this requires more for thinking. This requires sometimes more to pick up, etc. So, I have double circulation working. So, double circulation is the 2 pathways through which blood flows in the body. So, these are 2 pathways through which blood flows simultaneously. We can't say first, then second. No, both together. This is pulmonary circulation systemic circulation. At one time I'm using the blood, at one time I'm making the blood fresh. Okay? And both parts happen together. How does? So for the diagram purpose, I will use a square box or rectangle with 4 chambers. You can draw the same, but I do not want to waste the time. This is easy to remember. Okay? So this is my right auricle, this is my right ventricle, this is my left auricle, this is my left ventricle. Okay? First, when there is blood in my body, okay, first blood comes in left auricle. From left auricle, it enters the left ventricle. Where is blood coming from? Of course from lungs, where you are breathing. So I will write lungs. So fresh blood from the lungs, you do the T-shaped pulmonary. Okay? It is coming to left auricle, then through those valves, remember tricuspid and back, it is going down into left ventricle. From the left ventricle, blood will go to, or I will have to draw it a bit bigger, go through the body and return back to the right auricle. Now I will show a jump so that you are not confused. I can write both. Okay? So, left ventricle pure blood pumps, you see that systemic, then you go through the aorta, to the blood, the arteries, to the capillaries, and then you have reached the right auricle after blood is used. So this is, you can see, mainly veins, and this you can see is arteries. So this is the vein side, artery side. Then from right auricle, it will enter the right ventricle, and from right ventricle, it will enter the lungs. See, my circuit is complete. Now, if this appears confusing to you or something, I will just modify. You can see the diagram first, how it looks so neat and all. Otherwise, I will take it outside and write lungs here. Okay, and instead of writing lungs here, then they do not look confusing. You see, if you find them, you can make it bigger. So how bigger, how much you like. You see, now they don't look confusing. I have tried to draw small. You can make bigger. You can bring this guy here. This shows pi. So again, I remind you, blood is collected from precaval and postcaval from all parts of your body, comes to down and transported to lungs. Okay, then comes to left auricle after purifying, and then goes back to the body through left ventricle. This you can see is your aorta, and this you can very well see is your pulmonary. See, this is how blood is transported. The two X are here. So this is systematic, easy to remember. So this circulation is pulmonary circulation, and this is systemic circulation. Okay, so from the heart, blood goes to top portion, bottom portion, both collected to the heart, lungs for purification. Simultaneously, circuit, continuous circuit. This is how blood is transported in the body. I will now deal with last topic there, which is blood pressure. As I reminded you, that your aorta, so if this was my heart, okay, this was my heart, and blood is, you saw, came in, okay, came in, went, came in, went, and came in. Okay, this is what we decided. Now, my heart, and when the blood goes out, and my hand, now this is my hand. So if I tie that cuff here, doctor puts that cloth-like thing, then it pumps so that it holds tightly. So my blood vessel and the bag on the top touch each other. There is a bag in the cloth. So this is my blood vessel, which has come from the systemic. The blood vessel has come into my arm, and this is from my heart. This is my arm. So when I tie this band here, I believe I am taking equal pressure, because the U tube, liquid in the U tube has equal pressure in both the arms. So here is tying, then there is a pipe, he's got a bulb-like thing to touch, and the branch goes to a mercury U tube. So he pumps the air, the blood vessel and the bag touch each other, the same pressure is applied, the blood vessel is pushing the bag, so pressure is applied, and that pressure in mercury U tube we are reading. So we see here, in the mercury, I will draw single tube first, and then I will draw the box. So this is a stand, okay, and this is the mercury pressure. So I will see mercury rising, and it will return 120. There are all labeling, so this is how we measure the pressure. So blood pressure is measured. Sphygmomanometer. Manometer, U tube in physics is called manometer. Okay, sphygmo for the pulmonary, the air which you are pumping in, and oscillation which is deciding. This is also a blood pressure machine. Nowadays we have got electronic. You press the button, the motor will pump the air, and there is no mercury, but the circuit will show you figures. But this is what precise, that is not precise. Doctors always use this. Because how much you can push the mercury is your exact pressure. Digit, as you know, you're using calculator, watch, it can go fast, it can become slow. Mercury can't be fast and slow because you are pushing the mercury. Doctors prefer, that is why proper blood pressure, sphygmomanometer. We go for even digital if required. Remember that level should be same. You can't tie the cuff here, you can't tie the cuff here, number one. Number two, level should be approximately next to the heart. Number two, if you are sitting or lying down better, well, there should be no motion because you're oscillating the liquid. Be peaceful, don't clench, be normal so that the pressure is there. Don't apply more pressure and increase the pressure. Okay, so that's why blood pressure is taken first thing and taken 2-3 times to find the. When you get excited, pump it, and you get excited. How much will come? How much will? All brain processes will affect the blood pressure. Blood pressure is controlled by the brain. Okay, so this is what is blood pressure. And lastly, we have to see is platelets, because of the two things, chikungunya and how we get all these diseases. Blood platelets are broken cells of a big cell. Mother cell breaks down into small pieces, platelets. You throw the plate, platelets will form. These are now dead because you have broken the cell. They will decompose or decay, but they will take the time. RBCs also don't have nucleus. When oxygen is there, they break down more faster. They dissolve and release chemicals. These help in clotting of blood. Friends, I told you that your capillaries are taking oxygen to each and every cell. A cell does not have a needle inside like a syringe, injection and oxygen. How will the oxygen cross from a capillary wall into the cell? See, that is why there is liquid around each and every cell of your body. Body fluid. And in simple language, we call it lymph. Lymph is body fluid. So this is my cell. This is my blood vessel capillary. Okay, thin walled, very thin walled. Okay, oxygen will first dissolve in the liquid lymph, and from here will dissolve into the cell. Diffusion. CO2 will come reverse. First in the lymph and then into the another blood vessel, of course. But this is how it will exchange. So lymph is important. Without lymph, inside there is no hole through which gas is entering, there is no pipe, there is no needle. And second, WBCs will come from here, they will travel, WBCs like amoeba, and they go to fight. Anything wrong, they will cache around your cells. That is how diseases are cured. WBCs can enter or leave through the small gaps. That between those cells there are small gaps. They can go and enter through them. So lymph is important body fluid. If lymph dries, you have dehydration, you will die. You will have more infections, you will have problems. Too much of lymph, you will have swelling. Like old people have the joints and whatnot, because lymph is not flowing, they are not walking, the muscles are not pushing the lymph. Lymph flows in the gaps called lymph vessels. It doesn't flow in the capillary, vein, artery. So activity is required to push up the lymph. That is why runners and those who practice tie tight band around the feet so that a lot of liquid whole time does not go down and legs don't get swollen. Cyclist, policeman. Okay? So this is lymph, which is body fluid. So this is the end of our lecture on